Alright, so we're going to take a look at the secant functions and the cosecant functions. I'll do a variety of graphs here, but we'll start with just the basics so you get a feel of how these work. The cosecant function is really the reciprocal of sine. So I'm going to think of cosecant as being 1 over sine of x, which means I'm going to use a generic sine function to actually graph a cosecant. So I'm going to graph here just a generic sine graph. And this really isn't part of my cosecant, but I use this to guide me when graphing cosecant. And so basically what I want to do is look at these outputs here of 1 and -1. That's a negative. 1 and -1. And I'm just going to take the reciprocal of all the outputs. Well, the reciprocal of 1 is 1. The reciprocal of -1 is -1. So I know these 2 points are going to be on the cosecant graph. Let's take a look at the reciprocal of the outputs of 0. So wherever the sine graph crosses the x-axis, that's an output of 0. Well, the reciprocal of 0 is actually undefined. If you think about that, if I have 0 over 1 and I take the reciprocal, that gives me 1 over 0. So 1 over 0 is undefined, which means this is where we're going to have the asymptotes for our graph. The rest of it, we won't get heavily into the mathematics of it, but basically I'm taking the reciprocal of all these points on my sine graph. And when you start taking the reciprocal of every single one of these points on the sine graph, what happens is you get this shape here. It looks like a parabola. It's not a parabola, but it looks like one. And so there's your generic cosecant graph from 0 to 2 pi. We can do the same thing with a secant graph, except with a secant graph, I'm going to be thinking of secant as being 1 over cosine. And so we're going to graph just a generic cosine graph here. And again, we'll go from 1 to -1. And so this cosine graph now is going to start, looks a little bit different than the sine, obviously. Not part of the graph, not part of the secant graph. And again, I'm going to take the reciprocals. Reciprocal of 1, reciprocal of -1, reciprocal of 1 again. Wherever it crosses the x-axis, for the same reasons as before, those are going to be the asymptotes. And then draw my parabola-like shapes. Looks something like that. The graph doesn't actually stop here. It continues on, right? But I've set the window to be from 0 to 2 pi. So, I mean, basically that's what a secant graph looks like. Okay, so if we move on to something a little bit bigger, here's something that has it's just going to be a little bit tougher to do. But basically, what I'm doing right up at the start here is I'm looking at the secant function, and I'm thinking in my head, I'm thinking cosine. And so I'm going to be graphing this as if it's a cosine graph. So let's get some information here. We're going to set up the inequality and just quickly solve this thing to figure out what the horizontal shift is. I'm going to multiply both sides by 3. So that gives me 6 pi here. And then I'm going to add pi over 3 everywhere. So I got a horizontal shift of pi over 3. And let's see, I guess that's 19 pi over 3. So I have an idea of what's going on here. This is going to be my vertical shift. This is going to be the amplitude, or the A value. Alright, so I'm starting to get an idea of what this thing might possibly look like. It's got a horizontal shift. Tell you what, let's talk about the vertical shift first. So I'm going to make this, here's 2. Now, with this particular graph, it's got an amplitude of 4. I'll worry about the negative in a second, but that means I have to go up 4 units. 1, 2, 3, 4. And then I also have to go down 4 units. 1, 2, 3, 4. So this is going to be at -2. and that's going to be at 6. So that's going to affect this graph, obviously, in a interesting way. Here we're going to have pi over 3. Over here we have 19 pi over 3. We can get those points a little bit later. But to actually graph this thing, here's the middle of the graph. It's a cosine graph with a negative a value. So the cosine graph ends up looking something like this. This really isn't part of the graph, but I'm going to use it to help sketch my secant graph. All right, with my arbitrary x-axis, anywhere that this graph crosses the x-axis now becomes an asymptote. And I haven't figured out those values yet, but I'll get them. And then obviously the negative values and the positive values, those are going to be points on the graph. So I think I'm ready to sketch a graph of this thing. Basically, I'm going to have my parabola shapes are going to be up here. It's going to go something like this and something like that. Again, it continues on, right? But the graph really, I mean, this graph just goes from pi over 3 to 19 pi over 3. And that's it. That's basically your secant graph. If I wanted to fill in these values here, I'd have to add 19 pi over 3 plus pi over 3. So I guess that's 20 pi over 3. And then I take half of it, so that's going to be 10 pi over 3. This ends up being 11 pi over 6, and I guess this is going to be 29 pi over 6. Hopefully that's correct. I'm doing it kind of fast, but that's basically it. That's your secant graph.